In this video, I'll be walking through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 1-3. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video as you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around my channel. Okay, let's get into the maths. In question 10, we're given a curve they call C, and here's the equation of that curve. And we're simply asked to find the coordinates of the two stationary points. Now, to get marks here, you just need to recognize stationary points. Stationary points, we're talking about derivative. If you write derivative, you're on your way to getting your first mark. Next thing you want to recognize about stationary points derivative is the derivative equals 0. I think that will get you 1 mark, just writing that down. Because that's how we find stationary points. We get the derivative equals 0. Remember, the derivative gives us the slope. That's why they're equal to 0. So the question is, how do you differentiate this function up here? It's not too difficult. It's 3 terms adding together. This one, and this one. These are easy. The derivative of that is 0. The derivative of this is 2. So it all comes down to what is the derivative of 9 divided by 2x minus 5. It's not too difficult to do. A lot of students can do it in their head because you probably have done a question like this fairly often. You can use the quotient rule, something divided by something. Look up the quotient rule, go ahead and use that. We'll go ahead and use the chain rule. The chain rule tells me, well, first let me rewrite this as 9 multiplied by 2x minus 5 to the power of minus 1 plus 2x minus 5. This is just easier to deal with the chain rule, looking like this, the same thing. Chain rule tells us to ignore what's in here. Think of this as something simple. U is the most common thing to call it. So it's 9 multiplied by u to the power of minus 1. So minus 1 multiplies by the 9, we get minus 9. We get a u in here, or we're just going to leave it as 2x minus 5. And this goes up to the power of minus 2. That's the derivative if it was just u. But it's not just u. It's not as simple as that. We cheated basically by thinking of this as u. To fix that cheat, the chain rule tells us, well, let me just write here, dy dx would be the same as dy d something else, du. That's what I did here, differentiate with respect to u. To fix that, we just need to differentiate what u was and multiply. So differentiate what's in here, and that's just 2. Derivative of 2x is 2, derivative of minus 5 is nothing. So multiply it by 2. That's the derivative of this first part. Derivative of 2x, that's just 2. The derivative of minus 5 is just 0. This is the derivative. Put this equal to 0. You've definitely got yourself 1 mark. Probably should be 2 by this point. We just need to go ahead and solve this. There's one unknown here. Let's clean it up first. 2 multiplied by minus 9 is minus 18. This is 2x minus 5 squared, and it's on the bottom row, and we have plus 2 equals 0. Let's just start rearranging. Move the 2 over, we get minus 2. Put it up here. So we have minus 18 on the right, minus 2 on the left. This guy on the bottom row is dividing. Let's multiply the other side with it. So that's 2x minus 5 squared. Let's divide both sides by this minus 2. That gets us a 9 over here. And let's square this out. We get 4x squared. 2x by minus 5 is minus 10. Minus 5 by 2x is another minus 10, so minus 20. X plus 25, that's minus 5 by minus 5. Move the 9 over again, we get 4x squared minus 20x, and we get plus 16 equals 0. This is a quadratic. Also, everything divides by 4, so let's go ahead and do that. We get x squared minus 5x plus 4 equals 0. If you're not good at factorizing quadratics, go ahead and use the minus b formula. But this one isn't too bad. It's, let's see, x by x gets x squared. 4 by 1, that'll add together to get 5. So that's the answer here, 4 and 1. we need a minus 5, so it must be minus 4 and a minus 1, and they multiply back to get plus 4. So the answer here is x is equal 1 or x is equal 4. If you leave this as your answer, which so many students do, you will lose a mark. They did not ask for what x was. They asked for the coordinates. So you still need to find y. Let me just clear off a little bit here and we'll do that. So you now know x is equal to 1, x is equal to 4. We need y, but y is right here. Y is equal to 9 divided by, let's go with 1 first. 2 times 1 is 2. 2 minus 3 is minus 3. Plus 2 times 1 is 2. Minus a 5. Clean all that up. We get 9 divided by minus 3 is minus 3. Minus 3 minus 5 is minus 8. Plus a 2 is minus 6. The coordinate we're looking for is, remember we used x equals 1. We found y is equal to minus 6. The coordinate we're looking for is 1 minus 6. That's one of our answers. Do the same then with 4. Y is equal to 9. 2 4s are 8. 8 minus 5 is 3. Plus 2 times 4 is 8 minus 5. Clean all that up, we get a 6. So our other answer is 4, 6. There are your two coordinates. That's your full marks for part A. Alright, let me clear this off and we'll go into part B. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they ask us to determine the nature of each stationary point, and they help us out by telling us to find the second derivative first. That was just a clue that they wouldn't necessarily have to give you. To determine the nature of a stationary point, the easiest way to do that is to find the second derivative. So it was helpful that they told you to do that first. Here's y, here's the derivative of y. The second derivative is just differentiate this again. This is identical to what we did earlier, so I'll do it a little quicker. This is a minus 2. So we get minus 2 multiplied by 18, that's 36. This guy, minus 2 goes down to minus 3, so that's 2x over 5 to the power 3 on the bottom row. And we end up multiplying by this 2 here, the derivative of all this. So, sorry, I can skip a line here. That should be 72 then. So, sorry, I did that a bit quick, but it's identical to part A. And the derivative of 2 is 0. This is the second derivative. Now, how do you use the second derivative to determine the nature of a point? What were the points? It was 1 minus 6 and 4, 6. These were the 2 points. If we look firstly at this point here, x is equal to 1 at this point, and the second derivative has an x in it. So what they want us to do is to get the second derivative at x equals 1. Basically just put it in here, and what would we get? We get 72 over minus 3 cubed. That's 72 over minus 27. What you want to notice at this point is that this is less than 0. That means we have a maximum. That means this guy here, when x equals 1, we have a maximum. So when x equals 1, the derivative is 0, because we're at a stationary point. And the second derivative is less than 0. So that stationary point must be a maximum. That's what we've learned here. Do the same thing for the other point. The second derivative at x equals 4 is equal to 72. And on the bottom row, we would have 8 minus 5. That's 3 cubed. So it's pretty much the same thing. It's 72 over 27 this time. That's bigger than 0. That means that's a minimal. That means at this point here is a minimal. That's your 3 marks for part B. In part C, they tell us that this curve that we've been working with here is being transformed. It's by a translation of minus 3, 7. That's move left 3 and up 7. Then a reflection through the x-axis. C part 1 wants you to state the coordinate of the maximum point of C1. There's only 1 mark for this, and they said just state it. Don't need any working done. That means it should be quite easy. Now I think they were a bit mean here. I don't think it's that easy. I think it's at least 2 marks here. So they want you to state the coordinate of the maximum point of the new curve. That's very important, because the maximum point here, the maximum point is here. Let me do this question wrong. First of all, let me draw an XY axis. I'll put this point in here, 1 minus 6, and we learned that that's a maximum point. And then 4, 6, that's up here, and we learned that that's a minimum point. We don't need to worry too much about what the curve looks like. As it happens, when this is equal to 0, we would get a asymptotic line. So basically these will go off to infinity somewhere here in the middle. That's at 2.5. Somewhere here in the middle we'd get points going off towards infinity. Not important. What's important here is, there's a point here and it's a maximum, point here and it's a minimum. Let's go through, let's imagine you picked the wrong one. This one here, this one that's a maximum. And you tried to move that to the left 3. Let's put in some of these points. 1 minus 6. That would go to minus 2, minus 6. Up 7 would go to minus 2, 1. And then reflect through the x-axis. Fold it down. You'd come down here, you'd be at minus 2, minus 1. That could be an answer. A lot of students probably gave this as their answer. It's wrong. You're not going to get the 1 mark for that. Because look what happens. You move this left, it's a maximum. You move it up here, it's a maximum. What happens when it reflects? When it reflects down, it actually switches around to now it's a minimum. It's this point we should have been following. This point 4, 6. If we move him left, we get to 1, 6. If we move him up, we get to 1, 13. And if we reflect him down, we get to 1, minus 13. It's this point they were looking for. That's a minimum, a minimum, a minimum. But when it reflects, it got flipped upside down. It's now a maximum. That's what they want you to do. All that was just worth 1 mark. So I think that was a bit mean. I think you should have got at least 2 marks for that. 1 for finding the point and another for realizing the trick. Anyway, that's C part 1. Let me clear off a bit of room and we'll do C part 2. In C part 2, they want us to find the equation of the C1. That's this curve when it's moved left 3, let me write those numbers in, minus 3, 7. Moved left 3 and up 7 and then reflected in the x-axis, mirrored over that way. What's the equation of that curve? It's not that difficult to do because it looks a lot like this curve. If you start off with this curve, but instead of y, we're going to change y. And instead of x, we're going to change x. Let me write all that out. 2 times, instead of x, we're going to change something here. It actually looks like this curve. Or, no, this is going to be halfway through it. Because moving something left 3, or taking 3 away from x, and adding 7 to y, is quite easy to get the equation. Because it looks identical to x plus 3. Because remember, if I take 3 away from x, if I take 3 away from this guy, it will look identical to this one. Take 3 away here, it's like I didn't do anything. So it should look identical to here. So this equation should look identical to it when it's moved left 3. And the same with plus 7 on the y. If I add 7 over here, it's like I did nothing. So this equation here, if you clean it all up, which let's do it quite quickly, leave y on its own, and on this side we'd get 9 divided by 2x, 6 minus 5 is 1. Here we'd get, plus 2x, 6 minus 5 is 1, plus another 7, that's plus 8. This equation, it's not the one we're looking for. This isn't C1 quite yet. This is the equation if we just did this. So it's not actually that difficult to do. Most students just remember it's opposite to the sign of here, but I don't like saying that. I think there's a bit more of a reason to it. And then what happens when you flip through the y-axis? Well, we just see a drawing of this, but if we have the point, say 2, 4, when it flips down through, the x doesn't change. It's just the y changes sign. So we just need to change the sign of this y, which is the same as changing the sign of everything on the other side. Multiply both sides by -1. So the answer is minus this, minus here, minus it. That's full marks. I wouldn't leave it like that. Let me just write it out one more time. -9 over 2x plus 1 minus 2x minus 8. That's it. That's your full marks for C part 2. That's it for question 10. If you have any follow-up questions, let me know in the comments. Do me a favor and let me know what time or which section you're asking about. It helps me answer your question. Okay, thanks for watching and have a great day.